So I want to start with a little bit of a story on how we suffered through not having automation back in the day. One of my first jobs, I actually had a server right under my desk. I'm sure many of you must have done similar things where, hey, we're the software engineer in this tiny startup, and I'm also the sysadmin, and we have this server box, and let's make things work. Let's run a database and a web server and logging infrastructure, all in this one little box. It wasn't fun. A lot was hanging on this one little piece of hardware that was sitting under my desk. And we had to mature a little bit, so we said, hey, let's take this little server and move it to a co-location. So this is before virtualization, before any of that. We actually had to call a company like Dell and say, hey, we need to rack actual servers here, and mature and play with the big ones, right? So we went to this co-location. And just installed the base image, installed, configured Linux. Which version of Linux should we use? At the time, there wasn't really a good standard way to do all this, right? So we were just kind of figuring it out. And now we have this really beefy machine. How do I run more stuff on it? And so the idea of just running processes, it could work, but virtualization was starting to be a thing. And it wasn't the virtualization we know today. It was really kind of a lot of communities and companies kind of figuring out what level do we virtualize, what's para-virtualization, Zen virtual machines, VMware, all these technologies come together, and people like me and every sucker out there trying to figure out, okay, how do we make sense of all this, and how do we deploy it, how do we run it, how do we monitor it, which one should we use? It was just a really kind of fun, but also kind of scary kind of situation, because we as an industry were just kind of sorting through all this, right? So there was no standardization. Then came the cloud, and what I think about here is cloud providers saying, we'll figure out this virtualization stuff for you. Here's an API, hit this endpoint, we'll give you a machine. You don't even care what it is. Actually, we shouldn't. It's just, you're going to run some compute on it. Or whatever you want to run, here's how you should be thinking about this, right? So this really kind of revolutionized how we think about infrastructure and how we start kind of, building automation against it. So we've come a long way, from the early days of mainframes to more dynamic infrastructure and cloud, and everything in between. Now we're looking at not only kind of a public cloud, but we have these hybrid environments. So I have some on-prem infrastructure, some multiple public clouds environments, right? And so that creates new problems. How do you automate this, and how do you visualize, and how do you internalize and actually, understand the infrastructure estate, right? And this created all sorts of new problems. For example, 21% of companies have had cyber events due to non-sanctioned IT resources, right? So this is where people like me are going in and just provisioning, on the side infrastructure, and misconfigured something, or it didn't get tailored, or it didn't get kind of accounted for, creating kind of all sorts of problems, right? Similarly, 65% of cloud security issues start with misconfiguration. So this is what happens when, again, we're all trying to figure it out. There's ad hoc configuration happening. And finally, 30% of overspending happens with minimal cloud cost optimization strategy. So we're just over-provisioning by not having this sanctioned way to provision and monitor and work with infrastructure, right? So really, when we think about this, we went from more ad hoc manual infrastructure provisioning to more automated. We went from dedicated servers, as I had in way back then, to more on-demand capacity. We started talking about more long-lived infrastructure, short-lived. Servers come and go. I like to think of them as light bulbs. If they explode, if they go away, you just turn on a new one and replace it. It's easy. And it's immutable. This is a beautiful approach to infrastructure, is that you don't change it. Once you change it, it becomes kind of hot and it's weird and kind of a snowflake. We want to avoid that if possible. So the tooling that we created or that we need to support all of this, changes, right? And this is where the cloud operating model kind of comes into play. And we think about three major kind of tenets of the cloud operating model as it relates to infrastructure monitoring or infrastructure management, automation management. The first piece is golden workflows. And so this is, again, rather than having ad hoc folks, provisioning infrastructure, trying to figure out how to configure it, what sizing do we use, how do we configure networking, how do we secure it, there's a sanctioned way to do that. For everyone, and it's enabled for the entire organization to be able to, use the same tooling that's been sanctioned and that is well governed across the organization, right? And then the extensible system speaks about, the ecosystem around that. So whatever providers, whatever cloud infrastructure that you need, the system is able to interface with that and it meets you where you're at. So if you need different future public cloud providers or anything at all, the system allows you to easily integrate with that because it's so extensible. And we'll see about some other ways in which the systems are becoming more and more extensible. It's becoming more of a theme for us. And likewise, lifecycle management. After you've provisioned infrastructure, what do you do with it in day 2 and beyond, right? Provisioning is just the beginning, and once we've solved how to provision infrastructure, now we need to solve all the other problems that come with actually having all this infrastructure in a public cloud and multi-cloud environments. So it kind of creates new kinds of problems, right? And so really the cloud operating model drives infrastructure agility, and not only agility, but also security, because now the workflow is well understood and it's well governed across the organization, right? So let's talk about some of the new releases and features that we've put out as it relates to the golden workflow. But before we do that, for people, just to level set for everyone, the way this works is through this thing called infrastructure as code. Just really basically, it's about it's a strategy for bringing in kind of software engineering concepts into infrastructure automation. So you get all the benefits of that. You get Git or VCS workflows, and you get approval workflows, and you get rollbacks, and you get all these pieces that we kind of borrow from software engineering in general, testing, right? And so at the bottom here, we have you as a user writing infrastructure as code, using the registry to kind of pull in, say, modules and providers. Providers are, say, a public cloud provider. A module is how do you use this provider, or how do you configure kind of various provider resources to make that easier to deploy. And then what Terraform does is that it gives you a plan. Okay, what are the changes that need to happen to enforce this new configuration? Once you review that, you can apply it, and it actually makes the API calls in these public providers or public clouds and make that the reality, right? So that's the essence of how it works. This infrastructure as code is quite easy to read. And as I said, common patterns are encapsulated in modules. There's variables that you can pass around to enable reuse of these modules. And this language here is called HCL. And it's a very easy declarative way to describe infrastructure, right? And so this really speaks a little bit about developer experience. And when I think about developer experience, I'm thinking about simplifying optimal solutions. What is the best path? And let's optimize that without sacrificing maintainability, discoverability, or legibility. So I think about when we take that concept too far and actually make it a magic box, it's hard to kind of uncover and do. That's bad developer experience. But if the easy path is simple and easy, it's great developer experience. So these are some of the changes that we've made recently to improve the developer experience of using Terraform itself. And so one of them is, this is one of these optimal paths, right? Let's use Terraform Cloud with Terraform. And so this used to be a very convoluted process. Set up some remotes and figure out what to do about workspaces. So all of this is now encapsulated neatly into this one command called cloud, or one language construct there. So it makes it very easy to integrate with Terraform Cloud, Terraform Enterprise, likewise, right? And you can easily map workspaces from your local disk to Terraform Cloud workspaces, right? So this is, again, just simplifying kind of that optimal path. Another example is CDK for Terraform. So we've been talking about HCL as a way to declare infrastructure. CDK for Terraform says, hey, all of you, or many folks, are just application developers, not really infrastructure people, and you're already kind of in, I don't know, you're writing Python day in and day out. Just shifting from writing Python to HCL to configure infrastructure is a big context switch for a lot of folks. And so just meeting you there and saying, you can use Python, or you can use TypeScript, or Java, or C#, right, or Go. So that's what CDK for Terraform is here to do, is to help you just stay within the tool chain that you want and need to configure infrastructure, right? So it's a neat little project. We continue to kind of make progress on it. So next up is really excited about preconditions and post-conditions. The idea here is, to create these custom rules that can be enforced for resources, data sources, and outputs, right? So these rules, preconditions, evaluate prior to the associated object being evaluated by Terraform, right? So these you can use for making assumptions. And these are really useful for module authors, for example. If you are a module author for the community or just for your company internally, and you want to make sure that the variables that are being passed into the module meet certain conditions, in the past that was really hard to do. So now this becomes a lot easier. You can declare this. You can put in an error message that's clear for the user to understand how to resolve the issue, and just like streamlines that process, right? And so a post condition is after the resource has been evaluated and provisioned, let's set some guarantees. So here it's saying, this EC2 instance must be allocated a public DNS hostname, for instance. So really easy to kind of just declare that and make sure after provisioning happens, let's make sure this is out there, right? And this is a kind of new area that we're going into that is really related to all of you who've been using Terraform for a while and have very large configurations. And this is a huge challenge. How do you move resources and refactor that code? Hey, I want to take this pattern and make it a module and extract that out to a module. Well, in the past, or up to this point, that was really hard. It required you to go into manual state file surgery, which is really kind of risky, right? And so just having like a real supported way to do that, again, this is just the beginning. There's a lot of features and roadmap that we want to add to this idea of moved, the moved statement. But really, we want to help folks who've been using Terraform for a while kind of refactor their code and clean it up and move things forward, right? Which is a huge challenge today. So excited about that piece. And then let's not forget machine images. So let's talk a little bit about the golden image workflow, right? So just as how we have a golden workflow for infrastructure provisioning, similarly we have something we will have something for images, right? If you're running on a public or multi-cloud environments and you're provisioning images across multiple providers, all of a sudden you have multiple tools to deal with, and challenges with reconciling all of that and making that available to your customers, to your developers, having no visibility, governance, or control over that, right? So that's where HPpacker comes in. There'll be a whole talk about HPpacker later today, I believe 2:30 or so. So please join that if you're interested. But the common kind of goal of this product, right, is, hey, we have this base image. Maybe you pulled something from the public cloud provider, or you built it yourself using Packer, right? So that's our base image, and I want that base image to be used across the organization. Typically, you'll have, say, an operations team or a platform team kind of build that image, then pass it on to a security team who's going to add some tools or configure stuff or remove stuff from it, right? So all that configuration happens centrally, and then that gets pushed out to the organization, right? So the goal, again, is to have this like self-serve kind of scalability of infrastructure provisioning across the entire workflow set, right? So then we pass that image over to, say, there's a billing project, team who's wants to use that image, and they're going to add stuff to it. So they're going to add the application layer, data layer, or any other kind of tools that they need in that image, and go ahead and deploy that. And you might have even, a marketing project doing the same thing and pushing those images to other cloud providers. So what happens is, what if I want to update that common base image and deploy that across, right? So that's the kind of thing. It's like, today you just have no idea what's deployed where, and there's an OpenSSL issue in the base image, and we need to update it and push it out, as an example. So that's the kind of thing that HPpacker is going to allow you to start doing and thinking about. It's essentially kind of a registry for images. And you can see them all right there. And you can do things with it. So when we go manage it, one of my favorite things you can do with it is revoke it. Do not let this image be pushed out from now on, for example. Right? So really important tooling for security and governance, right? And also ease of use. So going back to the developer experience bit, right? This is one of my favorite things about HPpacker and Terraform integration. In the past, if you want to update the image, you maybe copy and pasted some variable or some image name, some crazy UID or something into your Terraform code to update the image. Instead, now what you're doing is you're saying, go use the image. Terraform's going to talk to HPpacker, get the correct image, and go use that. So now you can just update the images in HPpacker and make those kind of the golden, current image to be used, right? So really interesting early project, but super promising and exciting. I think it solves real problems for us, right? Again, there's a talk about this later today, I think 2:30, with product manager and engineering lead working on this, so really encourage you to go to that. So let's talk about extensibility. I think extensibility, to me, is like, well, first of all, over 2,200 providers. Amazing to see the ecosystem that's been built around Terraform itself. Really cool. But when I think about extensibility, it's really about promoting innovation and enabling use cases that we even haven't thought about. So the system itself allows you to hook into it to create kind of new workflows and solve new use cases that I don't even know about yet. And that is what's exciting to me about extensibility, right? And so run tasks is a really good example of this. I look forward to the things that you may be able to do with it. And it's really about giving you control to perform all sorts of custom actions. And the way it works, if you're familiar with Sentinel, Sentinel operates at the very same level where these run tasks run. The difference now is that run tasks are an actual webhook or an API call to an external system. And you can control the flow of Terraform's apply through the response, right? So right there in the middle between plan and apply is where a Sentinel check would have happened, or a policy check. That's exactly where right now you can provision a service and we'll issue a post API request into that system. With the payload, it'll have an access token. You can use that access token to get the entire plan that we're talking about here and analyze that plan and then respond with either a pass or fail, right? And by doing that, just controlling that execution. And so not only can you build your own run tasks and run them yourselves, and potentially I can envision like having a security team run their own run tasks, just analyzing plans before they go out, or doing your own cost analysis, or whatever you want to do in there. So I'm excited about that. But also we have over a dozen providers already ready to use with run tasks. And so these are everything from Snike, if you want to do security analysis, Bridge Crew, if you want to do OPA policy, right? Rather than Sentinel, go to town. That's all good. And many others, right? So cost analysis is another good example. We have infra cost. But again, I think this is going to keep expanding, and it's extensible in a way that you can use it yourself, which is awesome. And essentially, this show up right in the UI. The plan is here. We're running. We're going to do all these checks, and one of them failed, so we're not going to apply, right? Pretty simply, that's that. Now, to finish off the lifecycle management piece, now we have this like really awesome way to provision multi-cloud environments using a single tool with a golden workflow, and we can manage images. Well, now we created new problems. Now we have to understand our infrastructure estate. We need to understand our costs. We need to create new tools that provide a consistent workflow across all of these systems, right? All these clouds. So how do we manage that infrastructure after the fact, after it's been provisioned, right? This is kind of parts of what we're starting to get into, and one of the big ones is deviating from that golden workflow, how that creates drift. So first question is like, should we even allow that? Is that okay, right? Is it okay for someone to not use Terraform, go to the, say, AWS Consul and make changes, so that next time you're going to apply a Terraform change, the system's going to barf at you and you're going to be upset, and it's going to be very hard to kind of reconcile at a moment where you're supposed to be deploying infrastructure. So the answer is absolutely yes. I think there's actual cases where causing that manual changes makes sense. Break class scenarios, situations where there's an incident and you have incident response doing their thing. Right, we want to get out of the way and enable that. But this creates drift. And when it's created on purpose, that's fine. But what it isn't, it's actually a security issue as well, right? So we want to know about it as soon as we can. And so really happy to introduce drift detection. So this is now built into TFC for Business. It will be turned on over the course of the next few days. And it's going to do exactly that. It's going to check for drift on your current infrastructure. And here's an example of where it detected 3 instances that just drifted. They may have gone away. One of them went away. The others changed in some way, right? And so what we're doing internally is essentially we're going in a loop here. So first we provision infrastructure. And then we're going to do this loop of, hey, I'm going to check the infrastructure, observe something, detect that change. So essentially what we're doing here is like we're running a plan. And if that plan is empty, then nothing's changed. But the moment it's not empty, right, we want to notify you. So I'm excited about the notification too, because the notification could be an email that goes out, or it could be Slack, or any of our existing notifications, as well as webhooks. So now we're going back to the extensibility conversation, right? So now we have a webhook going out of the system. When drift is detected, you can use that to, page on call. If it's a production environment versus a dev environment, for instance, you want to take different actions. So all of that you can do automatically now through that remediation. And I'm excited about this loop because there's other things we can do with this loop, right? So on the more to come, what I mean here is we talked about post conditions, right? Those post conditions should be true essentially forever. And so just teeing up kind of this model that we have now around that loop will enable us to add more value in terms of those conditions that can be checked continuously, and just provide a workflow that's consistent around drift, all sorts of drift, that we'll have in the future with this system now, right? So to sum up, Terraform and Packer, a couple of tools that help you with the workflows around infrastructure provisioning for public cloud and hybrid environments, working together to support kind of scaled out infrastructure provisioning and automation. So that's it. Thank you so much.